Hello and welcome to the Chemistry Made Simple podcast. I'm your host, Matthew Macario, and this is the podcast where you get chemistry confident and we take you from point A to grade A. Hello, welcome back to the podcast. I hope you're well. In this episode, we're going to be talking about Hess's law, and we're going to be talking about how you can use the standard enthalpies of formation or the standard enthalpies of combustion to work out enthalpy changes because of Hess's law. So to start with, we need to define what is Hess's law. Well, Hess stated that the enthalpy change for a chemical reaction is the same regardless of the route taken. And in simple terms, that means the energy change will be the same if the reaction is done directly in a single step or indirectly via an intermediate step. And when you think about it, Hess's law makes perfect sense because it's a follow-on from the fact that there is a law of conservation of energy. If Hess's law was incorrect, if we were able to have a different amount of energy based on a different route, then we'd actually either be creating energy or energy would be disappearing. And just a note on that to avoid any confusion, if we're having an exothermic reaction, we might appear to be creating energy, but actually we're just converting it. As the law of energy conservation says, we're just converting it from chemical energy into heat energy. And with an endothermic reaction, the net energy is being changed from heat to chemical energy. So as a consequence of Hess's law, it's possible for calculation of the energy change of a reaction that doesn't happen directly or is inconvenient to do directly. The calculation can be done by looking at the energy changes of a 2 or more step process of getting from our reactants to our products. And in class, you'll be expected to do calculations to work out enthalpy changes when you're actually given data related to the enthalpies of formation or the enthalpies of combustion of the reactants and the products. You'll then be expected to use that in order to calculate the enthalpy change of the direct reaction, which isn't going to be a formation or a combustion. So how do we use that? Well, if we're given the standard enthalpies of formation, the way we would do that is by considering our intermediate step to all the elements required to make the reactants or the products. And it will be the same set because obviously the reactants and the products have exactly the same atoms present in them, just in a different combination. We can then calculate the total enthalpy of formation for all the substances in our reactants and the total enthalpy of formation for all the substances in our products, bearing in mind the number of moles that are going to be present of our reactants or product substances. Then we just merely need to do a calculation of getting from reactants via the elements to the products, what that would mean in terms of those total enthalpies. So in this case, getting from reactants to elements to products, our sum would be to have the enthalpy of formation of all the products less the enthalpy of formation of all the reactants. And the total of that, the sum, the calculation we would do, would be equivalent to the enthalpy of the direct reaction from reactants to products. But sometimes we'll be given the enthalpies of combustion, the standard enthalpies of combustion for the reactants and for the products, and be asked to calculate the enthalpy change for the direct reaction from reactants to products. Well, in this case, we need to understand that our intermediate step will be the combustion products of our reactants or our products, and our combustion products will be those formed if we were to combust all the reactants in sufficient oxygen or all the products in sufficient oxygen. The same products would be formed. Then we can take into consideration the number of moles of reactants present and calculate the total enthalpy change for the combustion of the reactants. We can do the same for the products. We can calculate the total enthalpy change for combustion of the products, again, bearing in mind the number of moles of product substances that are there. In this case, the calculation to get the enthalpy change of the direct reaction is to add the total of the combustion of the reactants less the total of the enthalpies of combustion of the products. That will give us the overall enthalpy change of the direct reaction. Okay, so what have we talked about today? We've talked about Hess's law and what it means that whatever route we take, we will have the same total enthalpy change, the same total energy change. We've said that's a consequence of the law of conservation of energy. Then we've said that we're often expected to do calculations where we might be given the enthalpies of formation or the enthalpies of combustion of reactants and products. And then we're asked to calculate the enthalpy change of the direct reaction, which isn't a formation or a combustion. And we've talked about how you can do that and how you can decide an intermediate step and construct what some people would call a Hess's law energy triangle. Okay, so that's the end of this episode. If you have any questions on this topic, then the best place to ask those questions is to come to our Patreon community at patreon.com/chemistry made simple. Ask those questions, and that's where I'll be publishing the answers to. I'll put a link in the episode notes so that you can find that more easily as well. The other thing I would say is if you're listening to this episode in the first few weeks after it's been released and you're interested in doing a follow-along online session of these types of calculations, then please do let me know. Again, you can come to the Patreon community or find me on Instagram at Chemistry Made Simple to let me know your interest for that. And also let me know what time zone you're in so that I can work out the level of interest in that so that I can help you with that. If you're listening later than that, then please also get in touch because I'll probably be repeating that from time to time. I know it's one of those topics that is best seen visually, and it's also one of those topics that, in my experience, a lot of students want to see, want to do, because they don't necessarily get it in class. Thank you for listening to this episode. I hope you found it useful, and if you have had value from it, do consider visiting our Patreon community at patreon.com/chemistry made simple, where you'll be able to ask deeper questions about this topic and get more support for your studies too. So I look forward to speaking to you again in the next episode, and until then, do look after yourself and goodbye.